Hey everybody, welcome to the fourth part of this video series where we are building a Minecraft clone in JavaScript. So on the screen right now, I have the final product of what we're going to be working on in this video, and that is a first-person playable character that you can use to walk around the world. So if I press any key, you can see that the browser captures control of my mouse pointer, and now I can freely move around the world. So I'm using the WASD keys to move around, and when I hit escape, then it goes back to the third person view, and then I can see this little indicator here of my first person camera. So we can turn this camera helper on and off just to kind of help us debug this first person camera as we're building it out. And I also have some options here to increase the player speed. So I can increase that, go back in first person view, and now I'm just zooming around the world as fast as I can. So in this video, I'm going to take you step by step through how to create this first-person playable character. So let's get to it. All right, so I'm picking up from where we left off in the last video. So the first thing that we're going to need to do is to create a new file to store our player class. So let's create a new file, and we'll call that player.js. Now the first thing we'll need to do is to import the Three.js library, as we have before. And then I'm going to go ahead and create a player class. Now, in order to implement this first-person camera, we need to take advantage of something called the PointerLock API, and this comes with every standard web browser. So I'm looking at the MDN web docs right now, and it explains everything about the PointerLock API that you'd ever want to know. We're not going to need to know the nitty-gritty about it because Three.js has a PointerLockControls class that we can use, which abstracts all of this away. But it's good to know what's under the hood that's driving everything. So the PointerLock API provides input methods based on the movement of the mouse over time. And it gives you access to the raw mouse movement, and it locks the target of mouse events to a single element. So it limits how far the mouse can move or go in a single direction, and this keeps the mouse within the browser so we don't run into issues where you're leaving the browser window and your mouse is now interacting with things outside the browser. And right here, most importantly, we can see that this is ideal for first-person 3D games, which is exactly what we're building. So now looking at the Three.js documentation, we can see that there is a PointerLockControls class that we can take advantage of. And this is an implementation based on the PointerLock API. And similar to the MDN docs, it just reiterates that this is a perfect choice for first-person 3D games in the browser. So it's very simple to implement. All you need to do is import the PointerLockControls class from the Three.js add-ons directory. And then it's just a matter of setting up the PointerLockControls. You pass in the camera and a reference to the body of the document. And then you add some listeners that detect when the pointer is locked and when the pointer is unlocked. And you can respond to those accordingly. So that'll be the first thing that we do is implementing these PointerLockControls. That'll allow us to switch between the third-person view and the first-person view. So first things first, in my player class, I'm going to import the PointerLockControls dependency. And I just copied and pasted this from the Three.js documentation. Now my PointerLockControls needs a camera, so let's go ahead and create our first-person camera. And that'll just be a new 3 perspective camera. So give that a field of view of 70, and the aspect ratio will be the inner width of our window divided by the inner height. And we can also set the near and the far plane for the player camera. So let's do 0.1 for the near plane, and we'll do, let's say, 200 for the far plane. Now let's also define our PointerLockControls. We'll just call that controls, and that will be a new PointerLockControls object that takes in a camera and then a reference to the body of our document. So right away when we create our player, I want to set the initial position for that player. So we'll do this.camera position set. And I'll just do 32, 16, and 32 to start with. Now when creating a camera, we need to make sure we add that to our Three.js scene. So let's go ahead and pass the scene in the constructor of our player. Then we can do scene.add, and then we'll add the camera. So let's go back to our main file, and let's create an instance of this player and pass that scene object in. So I'm going to find where I'm creating the world, and then right after that, let's create our player. And then we'll need to make sure we pass in the scene here. Now eventually we'll be updating our player state in the render loop, but we don't need to do that for now. So back in our player file, first thing I want to do is create a little helper method to access our player's position. So the player's position is just going to be the position of the camera, but it's kind of redundant to say this.camera.position every time. So I can define a get down here, and I'll just call get position, and this will just return this.camera.position. And so every time I want to access position, I can now just leave out camera. So we'll add a little documentation here, and this will be of type vector3. So we actually have enough now that we can render the scene from the perspective of our player. All we need to do is to go into our main file, and in the animation function here, when we render the scene, instead of using our third-person camera, we can instead use the camera on our player. Now, if we go to our game, let's see, we got a white screen here, so it looks like we might have an error. So let me bring up the console. So it looks like we're getting an error. Camera is not defined, line 6 of our player class. So I probably forgot the this keyword. And here's line 6, and sure enough, this should be this.camera. And there we go. You can see that we're rendering the scene from the first-person perspective, that new camera that we just added. So I can kind of change the scale of the world here. You can see things move around. But this isn't very useful because we can't move the player around. So the next thing that we need to do is to set up the actual pointer lock controls. So when we press any key in our keyboard, it'll lock in that pointer, and then we can use the mouse to move the camera around. So back in our player class, I'm going to add some event listeners in our constructor. Let's do add event listener, and then we'll do key down, and then we'll reference the on key down function here that we've got to define, and then we'll do add event listener for key up, and that will be on key up. So let's quickly add these event handlers, and then we can make sure we bind them properly. All right, so I've added our on key down and on key up event handlers that will get called anytime we either press a key or a key is lifted. Now to add these appropriately, we need to do this dot on key down, and then we need to bind to this as well. These events are triggered in the context of the document, I believe. And if we don't bind to this, then when we're actually in the body of this method, it's not going to know what the player is. It's not going to have any reference to that player unless we bind it to this. So we'll do a similar treatment for on key up. And let's just test these out very quickly. So I'll do a console log in here, key down, and then console.log key up. So when I press a key and lift the key up, you can see that we're getting some events here, getting some logs here in our console. So we know that our event handlers are working as expected. So now that we know that's working, we can delete these console logs. So what I'd like to do is when I press any key in the keyboard, it's going to lock that mouse pointer. So what I need to do is if this .controls is locked, so I'm negating this, so if the controls aren't locked, then when I press a key, I want to lock the controls. So all we have to do is this .controls lock. We just call that method there. Set a quick console log statement, just to make sure everything's working. Controls locked. So if we go back in the game now, and if I just press any key, we can see at the top of the screen, the browser has control of the pointer. Press escape to remove the lock. So if I press escape, I get my mouse back here. I can interact with our little UI on the side. And if I press any key again, you can see that the browser takes control of the pointer. And now I can use my mouse to move around in this first-person perspective. So that's great. That's exactly what we want. So now let's hook up the keyboard event so that when we press the WASD keys, we can move our player around. So let's start by going back to the top of our player class, and I'm going to define the max speed of the player. I'll set that to 10 by default. And then I also need a variable called input, and this is going to be a vector2. So in this, I'm going to store the direction that the player should move, forward, backward, left, or right, based on what key is pressed. And then in the player update method, it will use this input and move the player in that direction. So we need to set this based on which key is pressed in our onKeyDown event handler. So we'll switch on event.code, and then I'm going to add cases for the WASD keys. So when the W key is pressed, the Z component of the input is set to the max speed. Now if the S key is pressed, so going backwards, then we negate that. We go backwards by the max speed. Similar with A and D, we're setting the X component instead there. So when we press the key, we set the velocity, and when we lift the key up, we want to set that velocity component back to 0. So we need to do the same thing in onKeyUp. We're going to switch on that event code, but we're going to set these components to 0 when the keys are lifted. And this way our player won't just keep going in one direction indefinitely. Now these keys aren't going to do anything yet because we haven't hooked up the input to our player position yet. We need to apply that. So at the top here, let's add a new function called apply inputs, and then we'll pass in the change in time. So we are getting the speed, and we multiply speed by a change in time, then we get the change in position. So what we want to do is if the controls are locked, so you only want to move that first person camera when the controls are locked, then we want to apply that input to our player position. So before we do that, we'll just make sure everything's working here. We'll just do player update. I just like to always use these console log statements just to continually check my work, rather than writing all the code and then figuring out later there's a small bug I made and none of it works. So back in our main file, within our render loop here, so right before we render the scene, we'll do player.apply inputs. And we're going to have to pass in the change in time between frames here. We don't have that quite yet, so we'll just pass in a 0 there for now, but we'll need to calculate that. So how we do that is we get the time of the previous frame and compare it with the time of the current frame. We take the difference between those two, and that's the delta time, the change in time between the last frame. So we'll do a variable here called previous time. So I'm going to use the performance timer, and we'll just get the current time. We'll just initialize our previous time to whatever the current time is. And then within our animate method here, we'll define current time, and this will be performance.now. So the dt, or delta time, is going to be the current time minus the previous time. And then at the very end of this, we will set the previous time equal to the current time. And then when we do the next frame, we'll get a new current time. We'll subtract the previous time from that to get the dt, and then we will pass dt into our player apply inputs method. So I think it'd actually be helpful to, instead of printing this to console, I'll print dt, and we can see what kind of value we're getting from that. So going back to the browser here, let's open up the console. So we don't expect to get anything when the camera is not locked. Now if I hit a key here, we can see that it is now printing the number of milliseconds elapsed since the last frame. So it looks like we're getting around 8 to 9 to 10 milliseconds, which is pretty consistent with the 120 frames per second. I can actually click on this and it'll show the frame time here instead, which is 8 to 9 milliseconds. So that's making sense with what we're seeing in the console. So now we need to go ahead and finish out our apply inputs function here. It'll need one more variable, and that's going to be the velocity of our player. So that will be a new vector3. And I realized I actually made a typo here. The input should be a vector3 as well, not a vector2. So we're setting the x and z components just to be consistent with the way the world's laid out, where x and z are horizontal and y is the vertical axis. So going back up to our apply inputs method, we'll delete this console log statement. So first we need to set our velocity. So the x component is equal to this.input.x, and the z component is this.input.z. Then there are some helper methods on our controls. So we'll do this dot controls move right, and that will be this dot velocity dot x times the dt. So the velocity in the horizontal direction, we multiply that by dt, and we get the change in how far the player is moved to the right or to the left. And similarly, there is a move forward method on controls that we use. And in that case, we'll use the z component of the velocity, which is the forward and backward component. Now, one last quick thing that we need to do, the dt is in milliseconds. We actually need that in seconds. So we'll just go back to our main file here, and we'll just take this whole thing and we'll divide by 1000. Now, if you go back to our game and I press any key, you can see that right when I press the key, it locks the pointer. And now I can use the mouse and the WASD keys to move around the map here. Now, obviously, there's no gravity or anything like that. In the next video, we're going to work on the actual collision detection. We'll add gravity in and jumping, so we can actually move around the terrain and jump on the blocks. But for now, this is a good starting point. One thing I would like to do is actually display the position of the player in the lower right hand of the screen. That just kind of helps debugging, so you can kind of know where you are in the world. And if you need to go back to a certain point, you can kind of see where you were. So let's go back, and I'll open up the sidebar here. So I'm going to add some HTML and some CSS and get that player position in the bottom right of the screen. So right below the div for application here, I'm going to create a new one and give that an ID of info. And within there, I'll create another div and call that player position. Now we'll need some CSS to set this on the appropriate part of the screen. So let's go into our style.css file here and add in that CSS. Now, just walking through what the CSS is doing, I'm using a query selector for our info element. So that's the element that's containing the player position. So we're setting position to absolute and then setting that to the bottom right of the screen. Just setting the font to something a bit more readable and giving that a bit of margin just so it's not hugging the right of that screen so tightly. So we have the element added, we have the styling for it. So now let's go into the player class. And at the very bottom here, I'm going to create a new function called toString. And this is just going to output the position of the player in string format. So it's a very simple function here. We're just creating a string, and then we're just appending each part. We're getting the X component, the Y component, and the Z component of the player's position. So finally, all we need to do is in our apply inputs method here, we'll do document get element by ID, and I believe it's called player position. And we'll set the inner HTML of that to this .toString. Going back in our game here, let's close these controls. We don't see it initially because the camera is not locked, but the minute I press any key, we'll see that it locks the pointer and the position is being updated in the bottom right of the screen. So that will help us debugging later on. And in terms of debugging, I'd also want to add some UI controls to control the max speed of our player and also show you that camera helper that I showed you earlier. So I'm in our UI file right now. So when we're creating the UI, we also need to pass in the player object. And I'm going to add a new folder at the very top here. Call that player folder. And we'll add a new folder, give the title of player. So player folder, we'll add a new control here. So we'll get the player object, then we want to control the max speed. And we'll set the max speed anywhere between 1 and 20. Now we need to update the calling site for this. So that's back in our main file. So I think down here, there we go, create UI, let's pass in the player. So I can move around now. Player is moving at a pretty reasonable clip. So let me set the max speed to 20. And now we are cruising. Set the max speed low. And we're at a snail's pace. So one other thing I'd like to add is a player reset capability. So sometimes we might get into a situation where we want to get the player back to the origin. So what we can do in that case is I'll just bind this to the R key when we press that down. So when we press the R key, we want to take the position and we'll set it to 32, 16, 32. Then we'll also set the velocity of our player to 0. Now this doesn't matter too much right now because we don't have gravity, but if the player were to fall through the map, this would set that velocity component back to 0, so the player is just not flying super fast. So going back in our game here, let me get a bit away from the origin. And then if I press R, that will set me right back to where I started. So that is perfect. Now right now, everything is always looking through that first-person camera. I still want to be able to toggle back and forth between that third-person camera and the first-person camera. So let's go back in our main file. And I'm actually going to take this camera here that we defined previously. This is that third-person camera. And I am going to rename this. And let's rename that to Orbit Camera, just to differentiate it slightly from the player camera. So when we're rendering the scene, basically what we want to do, if the player controls are locked, then we want the player camera. Otherwise, we'll use the orbit camera. And we also need to make sure we handle the screen resizing for our player camera. So let's just copy these lines here and make sure that we are resetting the aspect ratio and the projection matrix for our player camera when we resize the screen. All right, now, so I start off in this third-person camera. If I press any key, it switches to first-person mode, and then I can press escape. It'll go back to that third-person camera. Now, it'd be nice to see where that first-person playable character is, so let's quickly add a camera helper to wrap up this video. So this is very easy to add. All we need is to add a new variable called camera helper. This will be a new 3 camera helper. Then we can pass in this.camera to that. And then right below where we're adding the camera to the scene, we'll also add our camera helper. I'm back in our game here. You can see this is sort of the origin point for that camera. Let's see if I can get a bit closer. So it's a little hard to see here. Let me try and contrast it against the lighter background here. So it's visualizing the near plane of the camera, which is sort of this small rectangle here with the cross, and then this very large rectangle back here. That is the far plane of the camera. And these lines are just drawing the perspective bounds, the frustum of that camera. So I can go in that first-person mode. I'll move my player to the edge of the map here. And then if I go back, you can see that camera helper is moved. This is really nice for debugging because we can always know where that player is. We can jump out in third-person view and kind of look around and see what's going on. So last of all, let's just add a UI control where we can turn this helper on and off. So on our player folder, add player.camera helper. And then let's control the visibility. Now these controls are also floating around a bit, so let's see, world size. Let's add these under terrain. All right, so now if I hit this toggle, it'll turn that helper on and off. Perfect. All right, so we now have a working first-person controller for our Minecraft game, so we can start exploring these cool worlds that we're creating. Now, the next steps is to get our player to actually interact with that world. So that's going to take a bit of physics to make that work. Now, we're going to be implementing our own collision detection in the next video. And I know that sounds a bit intimidating, but it's really only about 200 lines of code to do that. Because really, we're just taking a cylinder that's representing the player, and that cylinder is colliding with the blocks of our world. And those interactions are pretty simple. The math isn't too crazy for that. So thank you so much for watching. If you're liking this content, please be sure to hit the like button and subscribe if you want to know when the next videos in this series are coming out. So until next time, take care everyone. Thanks for watching.